Hello, good viewers. You are highly welcome. In today's tutorial, we are going to be solving this equation. We have 496 equals 2 raised to power n minus 2 raised to power n. So we want to know the value of n and m. For m and n are integers. Okay. So when they say integers, so they are counting numbers, right? So we can rewrite this equation like 2m minus 2n equals 496. Having that, so I want us to see that for we to have 2m minus 2n to be 496, so this is telling us that 2m is greater than 2n because this is positive here. 496 is positive. So for you to have this, it means 2m is greater than 2n, which implies that m is greater than n. So now since n is greater than n, so we can let m be equals to n plus k. So therefore m is greater than n by a particular value of k. So that's why we say m to be n plus k. So now from there, so we're going to replace anywhere you see m from this equation, replace it by n plus k. So that is, we're going to have 2n plus k minus 2 to power n equals 496, right? So from there, we can see that we can write this from the law of indices. We can write that as 2n multiplied by 2 to power k minus 2 to power n equals 496. Okay, so now from there, so we can see that we have 2n here, we have 2n here. So 2 to power n into bracket 2k minus what? Minus 1 equals 496. Okay, so now we're going to have 2 raised to power n into bracket 2k minus 1 then equals 496. So now we are going to express this 496 in both even, okay, and in even and odd. So 496, I can have it to be 16 multiplied by 1, so that you have one that we actually go with this 2 raised to power n that we have it. So you see what I'm saying now, 2n 2k minus 1, because we must look at the factors that will actually give us what we are looking for, because we are looking for the value of m and n, and they have to be positive. I mean, they have to be integers. Okay, so that is why we have to be very careful in picking the factors we have. So these 16 and 31, okay, have been observed, have been looked at. So now here we have 16 times 31, so we can see that we have 2 raised to power n, 2 to power k minus 1, which is equals, this can be written as 2 to power 4 then multiply by 1. Okay, so now from there, so what are you going to have? You can see that we can compare this and this together because they are having the same basis. We have 2n to be equals 2 raised to power 4, which implies that n equals to 4 because the bases are the same. Then also we compare this one and this one too. So we're going to be having 2k minus 1 equals 31, right? Then we have what? We have 2 to power k equals 31 plus 1, right? Then we have 2 to power k equals 32. So now from here you can see that 2 to power k equals, here 32 can be written as 2 to power 5 in index. Then this implies that k equals what? K equals 5. So I have n equals 4 here, k equals what? 5. But the value of n is only known here, so remain the value of m. So now we need to recall, we need to recall that m has been stated to be n plus k from what we have up here, okay, from this star here. So m equals n plus k. So therefore m is now going to be, what is the n we got here? N is 4 and k is 5. So we are going to have m equals 4 plus 5, we have 9. So now finally we have m to be 9 and n to be 4. So we have these two, where they are what they are positive integers, right? So they are integers. They belong to set of integers. So that's the end of the class. If you find the class very interesting, so do not hesitate to share this class to your colleagues so they can benefit from it. Then if you have not subscribed to our YouTube channel, consider subscribing today. Hit on the bell icon so that you'll be notified anytime we upload a new content. Thank you. Bye.